Hi, I'm Henry Brill. This is V3 ants. Yeah, hope you enjoy. Alright, so the first step is finding the gradient function, which I did. This is the derivative in terms of x, the I component, derivative in terms of y, j component, the partial. Alright, so first step, we got to, so assume I moves in that direction, I minus 3j, what is the rate of change? Alright, so to do this, we need a unit vector, so we have to turn this into a unit vector. Oops, I have the eraser. Alright, so we need the unit vector, which would be the magnitude of 1, -3. So magnitude of this, you can kind of do in your head. 1 squared plus -3 squared, and the square root of that, so 10 square, square root of 10. So now we divide the original one by square root of 10, so we get 1 over square root 10, comma, -3 over square root 10. Alright, so for this problem, we gotta find the directional derivative. And we gotta do that by finding the gradient at this point, where Aunt Allie's at. So if we were to plug in, if we have our gradient here and we plug in the point 1, 0, that will get us the gradient at that point. So let's see, f 1, 0. This equals, let's see, so we got 0, so -4, -3. This gives you a vector, -3, then comma, all right, we have 4, so -3, 4. All right, now you got to get the directional derivative, you have to dot this with this. So we'll do that right now. -3. And the order doesn't matter because it's the dot product. We could have done it the other way. Yeah. 4. So this gets us -3 and then -12. So it's -12 over square root of 10 plus -3 over, or sorry, yeah, -3 over square root of 10. So it's -15 over square root of 10. That's the answer for part 1. That is our directional derivative at that point. All right. Now for part 2, if we suppose we were to spear Aunt Allie with a normal line, what is the equation of this line? So we could do this by finding the tangent plane at that point. And then part 1. Okay, and then using that equation to get the normal vector at that point. So yeah, we have this formula to do that. All right. So we are at 1, 0. So f of 1, 0, which we know already is going to be 5. We got 5, so z equals, and then we have this, which we already calculated, or not directly, but the x component, the partial with respect to x with 1, 0, and so just this section, which got us, yeah, over here, we got -3. So actually, let's do this down here. And then we plus -3 times x, and then x sub 0 is just 1, so that. All right, now next part, so partial with respect to y, which we already did again, so that got us 4 times y minus, and then y0 is just 0. All right, excuse me. So now z equals 5 plus negative 3x plus 3 plus 4y. Now rearranging this, we got negative 8. Just putting the 8 on the other side equals negative 3x plus 4y minus the z, because we have to switch to the z as well. Okay, boom. So this gets us the direction for our normal vector, and we could the direction for our sphere vector or whatever, which would be negative 3 for negative 1. But to actually, make it the equation of the line, we do this, multiply, we have to make it an equation of a line. So this is the the direction component, and then the position vector, we could just use this point right here, and that'll get us our normal, or our sphere. So 1, 0, 5, and that's that. Boom. So I'll just call this like Alright, boom. Okay, now part 3. We got what is the two-dimensional direction fastest decrease. Okay, so for this we just do the magnitude of the gradient at that point, and since it's negative, since it's faster rate of decrease, it's negative. So negative, and we know that again, we already did the gradient, so it takes. And we know that f of 1, 0 gives us the gradient of 1, 0 gets us the vector 3, negative 4 from previous steps. So we just do the opposite magnitude of take the opposite of the magnitude of 3, negative 4. So we got 3 squared let me just write this out. Okay, boom. So now, opposite of this. 3 squared plus negative 4 squared. Square root of that, which gets us 5. Negative square root of that. So this gets us 5, and that gives us negative 5. So the rate is negative 5. What? Oh, so that's the rate. And then the direction would be the direction vector. So we got just 3, negative 4. So that's the rate. And then the direction is just the negative gradient. So, or sorry, no, the rate's not, sorry, the rate is just the gradient at that point. So, or the direction is just the gradient at that point. And just 3, negative 4. All right, boom. Okay, now, next part. Suppose you want to squash an alley with a tangent plane. Find the equation for this plane. So we already did that with the earlier steps when we found the sphere. So I guess, this is our equation for tangent plane right here. depending on the format you want it. Yeah, we got this right here. So this is question 4 as well. Okay, if the guts ooze down this path, find a vector that follows the path of the guts. All right, so we already know that the steepest direction is the direction of 3, -4. All right. Okay, so we already know that. And we now just need to find like I don't know how to describe it. It's like the change in z, because like we're on, the 3D plane now. So we already got the change in x, change in y for where they go, and now we have to find the change in z. So to do this, we can, oh, sorry, I didn't finish this. Okay, to do this, we gotta do, we can use this formula that I found online. Delta z equals the partial x, and then the change in x. And then we got f y, oh sorry, this is change in x, and we have the change in y, and then we got yes, that's our formula. I found this online. So we already know this, and we know the rate. So sorry, rate of change, which we know is 3, -4. So we could plug this in for that in for that. We know that the x component, what was that from way earlier? It's -3. Yeah, -3. So we got -3, and then the other one was 4. -3 times 3 plus 4 -4. This gets us -25. So we know the rate now. -25. So boom. That is that. All right, so now we now have our 3. So our final direction is 3, -4, -25. Okay, boom. So now, last step is we graph this. So let's go to 3D Desmos. And let's graph our let's graph all this. Sorry, I wrote all the equations down so I wouldn't have to go back and forth. Pulling them up right now. Alright, so the first one is the surface for xy. Okay, so this is our surface. Alright, now we got the points. On the surface, we are right here. Alright, so now we got our normal line. I did not put this one down. Okay, our normal line was this. We could I guess easier to rewrite this as parametric 3t plus 1, comma, 4t minus t plus 5. All right, so I think 3t plus 1. Wait, Okay, so